Hey everyone. I'll start by saying you are making me earn my keep today. I got quite a few problems to go over here. So we'll start with 2. The equation of a line tangent to the graph. So we need a point and we need a slope. They want it tangent to the graph of y equals x cosine 3x at x equals pi. So we already know the location. It's pi comma something, and we can just plug in pi to figure out the y coordinate. So the y coordinate is going to be pi cosine of 3 pi. Y equals pi 3 pi. It's going to be negative. Cosine of 3 pi is going to be negative 1. I'm thinking about the cosine of 0 being 1. Like this. So 0 to 2 pi. 3 pi is going to have a cosine of negative 1. So that's negative pi. So that's the y coordinate. And then we need to go on to find, obviously, the slope, which is going to require the derivative. Derivative is going to take a product rule. This is first function x times second function cosine of 3x. Within the second part of that function, there's going to be a chain rule. So first times the derivative of the second. I'll do it in parentheses. So y prime equals first times the derivative of cosine is negative sine of 3x times the derivative of what's inside of that, so times 3. First times derivative of the second plus second times derivative of the first, which is just 1. So when we clean this up, we get negative 3x sine 3x plus cosine of 3x. We're evaluating it at pi, so it's negative 3 pi sine of 3 pi plus cosine of 3 pi. All right, we've already done the cosine of 3 pi. That's negative 1. The sine of 3 pi, your sine graph starts at 0, increases to 1, back to 0, negative 1. So 3 pi, there's 1 pi, 2 pi, 3 pi is going to be 0. So this whole section is zeroed out because that's 0. So it ends up just being negative 1 there. So it looks like some of them are in point slopes, some of them are in y equals, well, we'll see here. We'll do y minus y1 equals m times x minus x1. So it's going to be y plus pi equals negative 1 times x minus pi. That would be D. Then you have me moving to number 3. Now number 3 I'm not going to do on a separate sheet of paper. I'm going to do it right here. Because this is the limit as h approaches 0 of f of x plus h minus f of x all over h. That is the long-winded definition of the derivative. That is f prime of x equals. So the derivative of some function equals the limit as h approaches 0 of f of x plus h minus f of x. So this is your function. F of x equals sine of 3x squared. So if I want the derivative of that, I'm going to first do the power rule. Bring my 2 out in front. 2 times the sine of 3x times the derivative of what's inside of there. So the derivative of sine is the cosine of 3x times the derivative of what's inside of that. So times 3. So it ends up being 6, because of the 2 and the 3, sine 3x cosine 3x. 6 sine 3x cosine 3x is option C. Next, you have me jumping to number 5. They want the derivative of this. I'm going with product rule. First times second. So the derivative is my first times the derivative of the second. Derivative of cosine is negative sine of 3x. There's a chain there times the derivative of what's inside of that. Plus second times derivative of the first, 3x squared. So when I clean this up, I get negative 3x cubed sine of 3x plus 3x squared cosine of 3x. which, let me take a put, I would probably see that 3x squared factored out, yeah. So you have a 3x squared factored out. They didn't make it negative, so 3x squared is going to come out in front. That's going to give negative x sine 3x plus cosine 3x. So 3x squared, the cosine of 3x, so that's a plus. 3x squared, the cosine of 3x minus x sine 3x, option E. Number 6. Again, when I look at 6, I'm just thinking basic. I would, one of two ways. You could do the product rule. You could see it as first being 2 sine x times second being cosine x, or I actually see the double angle, and this might give a totally different answer, and I might end up having to go back and do the product rule anyway. But 2 sine x cosine x is the same as y is the sine of 2x. And if I want the derivative of that, dy dx, derivative of sine is cosine, times the derivative of what's inside, 2. So I would get 2 cosine of 2x, which is option C. I wonder if I did the product rule, I probably would get something that would transition into the cosine double angle one, just to condense the answer. But if you see that double angle, that one becomes pretty straightforward. Number 9. You could do product rule right out of the gate, but I think it would be better always to simplify that function first. Cosecant is the same as 1 over sine, and tangent is sine over cosine. So right out of the gate, that sine cancels, and you get 1 over cosine, which is a secant x. And secant x, the derivative is just secant x tan x, which is option B. So using some identities here first is what we're seeing. Same thing here. You could do the quotient rule, it might get real ugly though, but when I see cosine squared, I'm thinking 1 minus sine squared. When I think 1 minus sine squared, I see the opportunity to factor and then cancel. So I'm going to change the function's look to that first because of my Pythagorean identity. Then on top, I'm going to go 1 plus sine x, 1 minus sine x, over the 1 plus sine x. I get that to cancel. And that's the function I'm going to find the derivative of. Life will be so much easier. So the derivative of the first piece is just 0, minus the derivative of sine is cosine. So this just ends up being negative cosine x. Last option over here, E. All right, so that's that sheet. 14. They want the derivative specifically at x equals 0. Just going to find the derivative first and then plug in a 0. Derivative quotient rule, bottom, times the derivative of the top, minus top, times the derivative of the bottom, all over bottom squared. Now this is one of those cases where you don't really need to clean it up. You can just plug in your 0 since we know what they're looking for. So 0 minus 1 is just negative 1. Cosine of 0 is just 1. Sine of 0 is 0. 0 minus 1 is negative 1. Negative 1 squared is 1. We end up getting negative 1 on top over 1 on the bottom is negative 1. Option E over here. 19. Second derivative. Is what they're looking for here. So I am going to go with just a chain rule. The first derivative is going to be the derivative of cosine is negative sine, so negative 4 sine of 2x times the derivative of what's inside, so times 2x is what's inside. So times 2 gives us negative 8 sine of 2x. Second derivative. Again, just a basic chain rule. So the derivative of sine is cosine. So this initially becomes just negative 8 cosine of 2x, but a chain because times the derivative of what's inside, so times the 2. So it's a negative 16 cosine of 2x, which is option E. And then 22 I feel terrible about. I'm pretty sure this is beyond us right now. I played around with it off screen because so many people asked about it. And I think I either made a mistake putting it on here or was like, wow, this is way too hard. Let's just at least put it on the review sheet so they're exposed to it just for some fun. So this video will take a while if I decide it's even worthwhile. So maybe I'll do it on a separate video. But honestly, don't lose sleep over 22. It's like crazy. So that wasn't as long as I thought. 11 minutes, not bad. Hope you're all doing well. Hope you're glad you don't have to watch any videos. And I hope tomorrow's homework is easier for you, especially after watching this. So, all right, we'll talk soon.